Hello everyone, welcome to my YouTube channel Exploration with Sejal. So now let's start with the vector analysis. The first question that arises to our mind that we are studying electrodynamics. So why do we need to study vectors? So vectors we need to study because the electric field and the magnetic field which we are going to study is a vector. So if we want to add or multiply, have dot product, cross product, all those things will come if we have to play with the magnetic and electric field. So in order to know all those properties of that fields, we need to study vectors. So what are vectors? Vectors are nothing but quantities which have both magnitude as well as direction. So for example, let's take force. So if I have a block of mass m and if I am just applying some certain force in some direction, the block will move in that particular direction. So that means the force has magnitude and direction. Then acceleration, electric field, magnetic field, then so on. There are so many quantities. You can name a certain, if you can think of certain vector quantities, you can write in the description. You can write in the comments. Now let's see the addition of two vectors. So we can add two vectors A and B. So before going to addition of two vectors, let me just tell you a vector is represented by an arrow and we can add two vectors. So we can add two vectors as A plus B is equal to B plus A, like they are commutative. Also we can apply associative rule to these vectors. And if I have a negative vector to this, like if say this is my vector A and if I want to add a negative vector, let's say this is my vector B, so that means I am adding a negative vector to it, something like this. Now let's see the multiplication by scalar. So if I have a scalar quantity, say small a, I can multiply this with the addition of two vectors, capital A plus capital B, small a capital A plus small a capital B. And now let's see the dot product of two vectors. So if I have vector A and vector B and if I want to have dot product between them, so basically we have two kind of products. One is dot product and another is a cross product. So dot product of two vectors is given by A dot B is equal to AB cos theta. So this is nothing but it's the projection of vector B onto vector A. So it is something like this, and we have the property A dot B is equal to B dot A. And we will see this in the upcoming things that dot product can be written in this kind of format wherein these AX, BX, AY, BY, AZ, BZ are the components of the vectors A and B. Now let's see the cross product of two vectors. So if I have vector A and if I have vector B, I can take cross product is nothing but the A dot B AB sine theta. So it is like if I have vector A here and if I have vector B here, I will take a cross product which will be perpendicular to both of the vectors A and B. So this will be vector C, which will point out in the perpendicular to the plane in that direction. So A cross B is not equal to B cross A, so it is minus of B cross A. That we need to keep in mind. Now let's see the vector algebra in component form. So I have vector A which can be written into its basis set AX I cap, AY j cap and AZ k cap. So I have this vector A, it will project onto this XYZ plane and this will be its AX component, then it will be having a Y component and it will have AZ component and so on. And if I have A dot A, that can be given as AX square plus AY square plus AZ square. It's just nothing but you need to just remember that I dot I is equal to 1, J dot J is equal to 1, K dot K is equal to 1. So it's like if I have I, so both will add and then it will give me AX square. then ay square, az square, and so on. So if we want to know the magnitude of one particular vector, let's say a, that is given by root of ax square plus ay square plus az square, like that. Now let's see the dot and cross product in component form. I mentioned you that we will see this in coming slides. So here it is. So we take vector a and vector b and we multiply them both. X dot x is 1, x dot y is 0, x dot z is 0, and like that if we do, we get ax bx, ay by, az bz, right? And also we can write x a cross b as into something called as this kind of what do you say, it's a multiplication technique to solve the cross products. So we can how we do it, this is a determinant basically. So we take I and we just multiply this ay bz and then az by. Then we take j and we put a negative sign to the second row, second column, sorry, and then this ax bz and az bx, like this we multiply, and we take the k and ax by and ay bx, like this we do. So this is how we solve a cross product. And in the coming videos we will see the vector triple products, the scalar triple product and the vector triple product, and so on. And then we will see what is a displacement vector, and then we will see what are how do vectors transform, like basically we will see rotation of vectors and so on. Thank you for watching and see you in the next video.